And I've got three main statements for you. So the first main statement is a stabilization on your derivative plot could be indicative of radial flow regime. What is radial flow regime? This is a circular flow towards the wall, and that is in the horizontal plane. The level of this stabilization is going to be inversely proportional to your mobility, kh over mu. K being the permeability in the horizontal plane, h your net reservoir thickness, and mu the fluid viscosity. Okay, let me repeat this first statement. A stabilization on your derivative plot could be indicative of radial flow regime, and the level of this stabilization is inversely proportional to kh over mu. So if I have a lower stabilization, I will have a higher kh. If I have a higher stabilization, I've got a lower kh. Second main statement. The vertical separation between your stabilization and the delta P plot, so if you like between the two plots, is indicative of the skin or the damage in the wall. A higher separation will mean higher skin, lower separation, lower skin. The third statement is that your shut-in duration, or delta T, could be replaced, if you like, by delta R, the radius from the wall. So as delta T increase, you increase the distance from the wall. Small delta T, you are looking near the wellbore. And what you might expect to see in most cases is a long unit slope straight line and a hump on the derivative. This long unit slope straight line, if you look at the log-log scale, so I've got one log cycle for one log cycle, this represents wellbore storage. So for example, when you start production at surface is going to be due to the expansion of the fluids in the wellbore. It's not going to be due to your reservoir contribution. You will have a time delay before the surface production becomes the same as the rate production. Inversely, when you shut the well in, your rate at surface is going to be zero, but your rate in the reservoir is going to be gradually decreasing towards zero, and you're going to have a time delay as well. Okay, so as delta T increase, you're looking further away in the reservoir, and you will expect radial flow regime with a stabilization, so circular flow towards the well. And at large delta T, you're looking even further away from the well, and what you might expect is boundaries. And a boundary will be represented by an increase in your derivative at late time. Okay, so just a quick recap, three main statements. A stabilization on your derivative could be indicative of radial flow regime in the horizontal plane. The level of this stabilization is inversely proportional to kh, permeability times net thickness. The vertical separation between the two plots is indicative of the skin, and delta T could be replaced by the radius from the well. Small delta T, you are looking near the wellbore. Large delta T, you are looking further away from the well. Right, let's have a look at an example with limited perforation. So this is a vertical well, limited perforation here, with perforation height equal to HP, and a reservoir with a net reservoir thickness equal to H. So intuitively, near the wellbore, you might expect a radial flow regime across this perforation height. Okay, so radial flow regime, then we'll expect a stabilization on your derivative plot. And this stabilization is going to be indicative of KHP, the permeability times the perforation height. Further away from the well, this acts as a sink point, and you'll have radial flow regime in the horizontal plane and across the entire net thickness. That is represented further away from the well, so large delta T. It is represented by stabilization, and that stabilization is indicative of KH, permeability times net thickness of the reservoir. This stabilization is lower, since this number is higher than this one. And in between, you will have a decrease in the derivative. That's due to an intermediate flow regime. In typical case with limited perforation, what you might expect for this intermediate flow regime is a spherical flow. Okay, you will have a spherical flow around the limited perforation, and you will see a negative half unit slope straight line. But this is not too important. So let's say you intervene in the well and you reperforate the entire section. So now what you're going to see near wellbore is a radial flow regime across the entire net thickness. If you take a PBU after that, what you'll expect then near wellbore and small delta T is a new stabilization indicative of KH. Now you perforated the entire net thickness. And this stabilization is going to be lower. Okay, so I stop my shut-in, let's say at 10 hours. But if I continue the shut-in period, then I will have consistency with this stabilization level. It's the same stabilization, the same radial flow regime. Okay, so now doing an overlay between different PBUs, we can quickly see, without doing any analysis, we can see what's happening.